So welcome to the workshop that introduces the topic of urban heat, and I'll also talk about how to use the thermal cameras, so I have a bit of manual part of it. My name is Agnieszka, but you can call me Aga, if that's easiest. Often people find it easiest. And I work at Western Sydney University within Sebastian Pfautsch's team, who is the leader in the topics about urban heat and how to mitigate that and how to improve microclimates in urban spaces. And he is also partially the owner of this equipment that you will be using today. And some of it also comes from LiveGo Hub. We will also have our building. And today I will talk briefly first about the urban heat as an introduction. Then we'll have a little bit of manual how to use the devices. So we'll have step-by-step how to use them. And then we can go outside. Hopefully the weather improves, we have more sun. You can go outside, you can use the devices, you can ask me questions, and you can have a look at different surfaces and shaded or unshaded parts of these materials. And I'll start with a little bit of background, but you probably all know it anyway, that climate change is increasing the ambient temperatures, often is leading to more frequent, prolonged, and intense heat waves. And people living in urban spaces are particularly at risk of these high temperatures because urban environments, whether it's a large city or a small town, they are hotter than the surrounding non-urban environments. And it's important to talk about urban heat because heat actually harms people. High temperatures have a negative effect on our health and well-being. And this is actually a graph that shows you the temperature changes for the state of New South Wales. Those were calculated as a relative to the average between 1971 and year 2000. And the blue bars here represent the cool years and the red bars the hot years. So when you look at this graph, you can see that roughly before year 2000, we had a large number of cool years. But since then, the number of hot years increased, with some of them being hotter than the previous one. So what this graph really tells us is that our climate is changing, it's getting warmer, and that's not a trend that only occurs in New South Wales, it's across the continent and globally, and it's most likely to continue. And I did mention that the urban spaces are hotter than the surrounding non-urban environments, and this is actually a phenomenon that is called urban heat island effect. And it's the surfaces and the air that are warmer in the cities than outside of the cities. It occurs during the day and night. But it's not just the outdoor temperatures that are uncomfortable during that situation, during this heat island effect. During hot days, especially in summer, during heat waves, the indoor temperatures also increase. And this increases the need for cooling. And this means that we use more electricity. Our bills are getting higher as well. So there are larger implications. And this urban heat island effect occurs when we replace these green and open spaces that provide cooling with built environment that leads to warming. And here I have an example of micro-scale urban heat island effect. And this is one of the suburbs in Western Sydney. You can see there's a little bit of urbanized space, there's forest nearby, and the thermal image reveals their surface temperatures because these devices that you will be using today, they do not measure air temperature, they measure surface temperatures. And you have a scale on the right-hand side, which in purple and blue shows the low, and in red and white, high surface temperatures. And you can clearly see that urban space is hotter than that forest nearby. And actually the hottest part of that built space are the roofs. They are often dark in color, and because of that, they absorb a lot of solar radiation, and they will store that heat, and that heat actually is transferred inside of the building, increasing the indoor temperatures. And you also can see that these roofs are hotter than that asphalt road that is surrounding that space. And there's also artificial grass in front of one of the buildings, and it's just here. So you can see that there is an impact of the hard surface that we introduce into our spaces. And you can also see that within that built space, there's quite a variation in these surface temperatures, because there are several factors that will determine that surface temperature, and I'll show you that in a minute. Because surface types are determined by material type and its color, and whether or not they are shaded. And here I have an example of 5 different surface types. We have white gravel, we have dark paver, we have green grass, and below you have concrete, one that was light in color and one that was painted black. Very common surfaces. You probably seen them everywhere. They are very typical for urban environments. At the top, you have the temperatures that are extracted from those thermal images. And here is the thermal image that shows you really how they appear when the image was taken. The scale shows you in blue low and in red and white high surface temperatures. And you can see that the white gravel and the light concrete, they had very similar color. They were around 52, 54 degrees. Then we have the dark paver, which is more of an orange color, indicates higher temperature, and was actually 57 degrees. This green grass is the coolest surface that was captured within that image. It was around 41 degrees. And the hottest one was this black painted concrete. That black painted concrete was 63 degrees, was 20 degrees hotter than green grass, and 10 degrees hotter than the same material that was light in color. So this highlights the differences in surface temperatures depending on material type and its color. And now imagine having an urban infrastructure like car park that is quite large in size. There's no shade and it's covered with asphalt. This means that this car park will absorb the solar energy. It will increase the surface temperature within that car park, and that heat is stored within that car park as well, within that asphalt. And it's not just the hot surface. That heat will be radiated back into the environment, warming the air temperatures as well. So this has bigger implications. And this is a slide that shows you the effect of shade, because shade can efficiently reduce surface temperatures. Shade can block solar radiation from reaching these materials, like, for example, asphalt, that are heat retaining, and therefore reduce their surface temperatures, and the heat is not accumulated to the same extent as if it would be exposed to the sun. And therefore, this energy is not emitted back and it's not warming the local air temperatures. So this is actually an example of a car park in Western Sydney. It was covered with asphalt. It was black asphalt. And there was some shade structure in a form of solar panels. And I can clearly see there's a huge difference in temperature between the sun-exposed and the shaded asphalt surface. And in fact, it was 30 degrees difference. So a huge impact of shade in reducing surface temperatures and improving the local microclimate. And now think about the cars that are parked underneath that shade. If they are parked in a shade, means they are cooler, right? They are cooler, there's less likely that you have to turn the air conditioning to actually be able, and it's safe for you to use that vehicle. You use less energy, you use less petrol, and you emit less CO2 into the environment. So there are other implications of having that shade in urban spaces, especially if you have materials like asphalt that will retain that heat. And last Saturday, I was in Portland, and I had a similar workshop to this one. It wasn't really a hot day. It was 26 degrees forecasted in the afternoon, which normally would be achieved at probably 3 or 4 o'clock. It wasn't a very sunny day. It was a little bit of cloud cover. And we were walking around. We found this playground that had no shade. And it was covered with this soft fall material. It was dark in color. And as you can see, it reached very high temperatures. So 45 degrees that we measured during, I think it was 1 o'clock that we measured that. And it's possible that this is a heat accumulated from a day before. It was Australia Day. You know that it was very hot. There was a lot of solar radiation. And it's possible that it was still within the structure of that playground and retain that heat. But if there would be a shade, we could minimize this surface temperature and then improve the playground environment. I think that's a good idea that you grab the camera kits and we go through this together now, because that's the best way to have this hands-on experience. So if you can grab one thermal camera each, I think we should have enough. And if not, you can always share.
Yeah, we can share. We've got one.
So to open them, you need to press down this gray part, and then it will open. You just need to, this way. It's quite tricky, but, and just be careful at the top there's iPad, so it doesn't fall when you're opening.
That's quite a test.
Yes. If anyone has trouble, just let me know. So what you'll find there will be obviously that thermal camera, which you probably notice is very small, and that's the idea because it's cheaper than the actual more advanced ones. But it doesn't work by itself. So it needs another device with a screen, and that's why you have an iPad. But it could work with an iPhone, so you could technically connect this to an iPhone. So yes, you need another device to actually see what the camera sees. The battery is not very long-lived. It's with constant use, it takes 45 minutes to 1 hour, but it's easy to charge, so there's not an issue there. So that's what the kit's containing. And then the first step that we'll have to do is you have to take the iPad and turn it on. So you will see at the top right corner, there is a button that you have to press. It's just here at the top. I can put it down if you want. So when you press that button, hold it, after a while you should see that Apple icon, and you will see it will ask you to provide a password. And all these devices that you have now, they have actually a password written on the back of the device. So you will see something like that, so ask you to provide a password, and the password is a 6-digit number. So it's the 091910.
Okay,
It usually starts with 09, 19, or 18. Everyone good? So once you have it on, you actually need a special software to run and use the camera. And that's the icon that you can see here, and it should be very easy. Some of you already have that on. You should press it, and then you'll probably see something like that.
You press camera?
No. So you have to press that first icon on the top left corner, flare up. It will take a while just to open and so on, but you'll see something like that. And the actual software tells you what's the next step. But before we actually go there, I thought it would be a good idea to tell you what the camera actually has. So it has a connector that goes into the device like an iPad or iPhone. And you can see there are 2 lenses. So the top one is the visible camera. So it takes standard images like your phone will take. And the bottom one is actually the thermal camera and takes these thermal images. So in fact, when you take a photo, it takes 2.
Great.
So you have the standard image and the thermal image together. And at the bottom of the camera, there is the on and off switch that you need to press, and it will take a while for the camera actually later to turn on, but I will explain why. There's also the USB-C port that's for charging, and there's the LED light that indicates you the status of the charge. So you probably all started connecting this anyway, but yeah, you just simply need to connect and then press the button and so on, and usually takes few seconds to start. Don't be alarmed if this doesn't happen straight away. Because the camera goes through a calibration process. You will probably hear the flicking noises, and that's very normal. That's the calibration that the camera goes through. And you'll probably see something on the screen as well. So that's your indication it's working. Everyone good?
Let me get a photo of this. That's so cool.
And obviously you can plug the camera either way. So you can face, the lens can face you or can face away from you. So depending how you plug it in. And I think a good tip is, so when you'll be taking the images, keep the camera at the top of the device. Often when you walk, you may actually bump or knock the camera and may break. So it's a good idea to keep it upwards, because this prevents this potential damage that may happen. Yes, yeah.
The person doing it.
Yes, so you need to just rotate the camera other way. So it's facing you. If you unplug and unplug it the other way, it should face the, you can do both really.
Okay, so if the camera's photographing you, that means you've got the camera pointing in the wrong direction.
Yeah, sorry, I forgot to mention that.
Is there a way to recalibrate? I've noticed that the hotspots seem to be a little bit off the image.
Because you have actually two images here, so
Yeah.
it's blended in. I think there's some calibration. I didn't do that calibration in the past, but yeah, there's some, yeah. So those don't really need it because they were barely used. But the more advanced ones, they have a special tool to actually calibrate them and align the two images together. Yeah. But for those, it's not a big issue. And the thing that you can see now, it's just simply you have two images blend, which I will tell later about. So this is not an issue right now, but in the future, if you actually take the camera from the library or from here, and you find there's actually a gap between your camera and the iPad, there is this small dial or knob that you can rotate left and right, and it extends or shortens that connector. So for example, if there will be a protective case on the iPad and you will need more space, so you will need to extend it. And also it's a good idea to avoid that gap between the devices. Again, this is more of a safety. If you are walking and you will knock the device, it may break that connector. So just a tip so you know for the future that you can actually adjust that connector. So now it's the time to actually access the menu that you'll find by pressing that small arrow. And if you go into that menu, you'll see 4 options. And I'll only talk about the first 3. The auto manual, that's not something that you should be concerned. This is calibration process. If you want to learn more, I invite you to check the website from FLIR and you can have a look. But they were barely used, these devices, so they don't need it. So start with the photo mode, which is more of a user's preference of what you want to really see on your screen. So you can select 3 different options to visualize the temperatures. So you can have a standard and thermal image blend together, and that particular option provides you with more details within the image because you have the thermal and standard image blend together. Then you can select the thermal image only, which when you flick between these two, you will see there's less details. So that's an option as well. Or you can have a standard image, which is the normal image that your phone will take. But I recommend using the first or the second one because what you really want to see is the temperature. And this is very similar to the phones that you have. To take the photo, you just simply have to tap this wide round button. There's a smaller one with a red dot for recording videos. So there's an option to record a video as well. So for example, if you want to see something over time, how the temperature changes, that's something for you to use. But just keep in mind the constant use of the camera, it's usually 45 minutes to 1 hour. So something to think about when you do such an exercise. And whether you take a photo or record a video, they are automatically saved within the iPad. So nothing is stored on the cameras. Cameras are only used to take the photo. Everything else is actually stored within iPad. And you can access these images through the iPad gallery, or you can access them through the software gallery. And you can find it on the top right corner, this small icon. If you press it, it will bring you to the gallery of the images that were taken. Some of these devices actually may have some default images already there because that's what it comes with. And here's, for example, an image that shows you the heating in a floor. So normally with the standard image, you wouldn't see it. But if you take the thermal image, it reveals where this actually is located. So these devices not necessarily have to be used for detecting heat. If, for example, there is a leak in a wall, these cameras could record because water cools, so the space will be cooler. So it's not necessarily just the heat that can be recorded.
So this could help in winter if you're trying to work out why you're getting cold into your house.
Yeah, for
So
example.
you can find all the leaks where heat leaks out and where cold gets in,
Yes.
so that you can warm your house in winter.
Yeah, that could be used for that as well because it measures the temperatures. It doesn't matter whether it's the high or the low end of it. Yeah. The second function is spot meters within the measurements. So a spot meter is simply just a small dot that you can place on the screen. And you can place up to 3 spots that will be static. So they will not be moving around unless you manually move them. And to move them, you just need to pretty much just press and hold for a few seconds that particular dot and then move it around and place it wherever you want. And these dots provide with a value for the temperature for that particular spot. So it's more handy if you want to know actual value for that temperature or that surface and so on. And there are 2 additional spots that you could select, which are called hot and cold spots. So they are not static. They will be moving around your screen because their aim is to find the hottest and the coolest spot within your image. And then you can see on the left-hand side, I have a screenshot of when you have them all enabled, that's what you will see. They will provide you with these values for the temperature. So it can be handy if, for example, you want to know what's the hottest temperature within your image. And the last one is called color, which is again user's preference. So here you can select how you want to visualize these temperatures. So you have different color palettes that you can select from. I leave it up to you what you want to really select. I personally use the rainbow or contrast because those are giving the best visual representation of the temperature. The selection here doesn't change in any way the measurements. It's purely just your own preference how to display the temperatures. And the last thing that I will mention is that there are additional functions within the application itself that you can access on the left top corner. So things like you can change the date and the time, you can change the unit from Celsius to Fahrenheit. You can also enable geolocation. So when you take a photo, it will save the coordinates where this image was taken. There's also the status of the battery, so you can see how much battery is left on the camera. And there's also a parameter that is called emissivity. So it's pretty much a measure of how efficiently an object radiates heat. And it ranges from 0 to 1. So 0 will be a mirror that will reflect most of the energy, where 1 is the surface that absorbs and radiates energy. And the FLIR provides a table with all these values and different surfaces. So if you're interested to know more about this, I recommend to look into that table and the manual. But the default value for most surfaces that you will find anywhere really is 0.95, and that's what they recommend to use, unless you have this more specific, more like a mirror that you want to take image of and so on. But otherwise, this is the value to use.
Oh wow, that's really high.
Yeah, it is high. Yeah. So this covers most of the surfaces. Yeah. We barely change it.
Grass, do you know?
I don't really know. Yeah. But you could actually check it on that table. But this is mostly what we do, and even if you take a photo in the process time, so you don't really have access to that software for processing, but you can typically change that value anyway. So if you made a mistake, you take a photo and then something is weird, like for example, you have a metal slide and you can see it doesn't really read very well, you can change that value. So after processing.
Oh, cool. Yeah.
So if you want, we can actually go outside. I can see some sun.
Oh, really?
Yes.
Amazing.
Yeah. I don't expect that you will see huge differences today, unfortunately, but you can borrow those, so then you can use them on a hot day to really see the differences. And if you do so, look at the different material types, different colors, shaded or unshaded, and you will really see the differences.